Hello everyone and welcome to today's webinar. My name is Antonio. I cover sales in the US and I'm here with Adam doing sales and business development in Canada. And we also have Martin, who is the head of our R&D department in Germany. The idea for today's webinar is to present and show you a new product we have developed called ISOshade. However, before we start, I would like to say that a recorded version of this webinar will be available and we will also attach this presentation. All of these will be shared with you via email after we finish the presentation. At the end of the presentation, we will have time for any questions, so you can post questions in the chat. There should be a chat button somewhere in the menu, and you can use that, and at the end, we will review them. I would like to start with a brief explanation of what we do at Seele and why we have developed ISOshade. Most of you will know Seele for designing and executing glass and steel bespoke solutions. This is considered our bread and butter. Our work is project specific rather than focusing on specific countries or cities. We like to say that we go where the project is located. So here we show some of our projects located in different parts of the world where we show different glass solutions. For example, we have projects with all glass structures like the Apple Cube in New York, to a unitized tower in Frankfurt, or a grid shell roof in Melbourne, Australia. Today, what we're here to talk about is ISOshade, which is not a bespoke in the same way as our project work. Instead, it is an off-the-shelf product that can be purchased and installed by anybody. In very basic terms, it's a super high performance and a smart insulated glass unit that includes integrated sun shading, and ultimately it can be sold as a product. And why did we develop it? This is purely based on demand. More and more, our clients demand facades with high performance requirements. So what do our clients normally expect from our facades or from any facade? Number one is thermal comfort. This means protection in the summer, solar gain in the winter, and a way that we can also control sunlight. Then protection from a safety standpoint and also from a sound insulation. Space is also important. ISOshade has minimal facade depth. Deep facades with multiple layers like double skin facades take valuable space. Energy efficiency. For example, last year here in New York, Mayor de Blasio spoke about banning glass facades that don't perform or are not sustainable. Flexible design. Even though ISOshade is a product, the design can still be flexible. Here what we see is what an ISOshade panel looks like. The depth of the unit can vary between 5 to 7 inches, well, depending on the type of sunshade and glass buildup. So depending on the sunshade, if it's wider, then the full buildup of the unit will be on the 7 inches, and if it can be reduced, then to 5 inches. The height for a standard element varies between 40 and 160 inches. The width is limited by the raw glass production at 126 inches. Taller panels are possible, but then this will be considered a special order, and the maximum height for this would be 275 inches. The buildup, so if we look at the buildup of this unit, starting from the outside, we have a double or triple insulated glass unit. Then we have the pressure equalized cavity where the sun shading is located. And on the exterior, we have either laminated glass or monolithic tempered glass. The motor to operate the blind is integrated at the top of the element, and access to the motor is possible for maintenance reasons via a cover plate. So if, for example, the motor broke, it can be replaced. Usually the motor is what breaks. So what makes ISOshade so unique? The protected and integrated sun shading means that there is no wind and no cleaning required. The units are also pre-assembled, which means one element and also fast installation, which is important in city context. For example, in New York, installation is normally considered one of the most expensive parts of the project. So easy installation and pre-assembly is important. We also like to say that plug and play comes into the equation, which means it doesn't need any piping or mechanical or electrical installation. Excellent noise protection, which is also great for urban areas. We also have reduction of heating and cooling cost by being able to control the solar energy. It is also energy efficient since there are no operational costs and also no cost for ventilating the system. All components are recyclable, such as the different components that make up a unit is metal, glass, and silicon. The units are also maintenance free, and this is also very important since they are sealed in the shop and have pressure equalization system in the cavity. That's the technicality of how it works, which is a pressure equalized system. Some of you may ask, what is the difference between an ISOshade and a double skin facade or a closed cavity facade? The double skin facades have been around for quite a few years, and several examples exist. The facades are made of individual layers, making it expensive to maintain. With ISOshade, what we have is we are bringing all these individual layers into one 5-inch panel. And as for the closed cavity facade, I would say that the biggest difference is obvious when we look at running cost during the life of a building. So closed cavity facades require constant air pumped into the cavity. This is not only unsustainable, but it also has huge cost for running the facade. ISOshade doesn't need mechanical air since the pressure equalizes via filters. Now, on the next slide, Martin will take you through the technical details of how it works.
Okay, hello from Germany. This is Martin. What we are showing here on this slide is a couple of, let's say, parameters you can drive for the ISOshade. So this is one of the main advantages of systems, like Antonio pointed out. We can change all these variables really depending on your needs and on your requirements. So the sound insulation system for a double layer facade system is of course very good, and these values shown here, 37 to 45 is a typical range. We can even go up to about 50, 51, depending on the glass buildup we are using. For example, with a triple IGU and some sound insulation foils, we can achieve about 50, 51. The solar heat gain coefficient is driven by the sun shading we are using and also the selective coating we have on the glass, which you are totally free to choose. Typical values are about 8% when the sunblind is closed, up to 50%. But again, you can even go down to about 6% when we combine this with a highly selective solar control coating. The thermal performance, the insulation property of the ISOshade is mainly driven by the insulated glass panel we have on the inside. So if I have a 3-fold IGU, it's typically about 0.6 in European units or about 0.11 BTU. Again, you can also use a 2-fold IGU if that's enough for the insulation requirements. We are only using non-combustible materials. We're using glass, metals, some sealants, and they are of course combustible, the sealants and the gaskets, but they're only a very small percentage of the total product. So it would be classified as A1. And depending on the glass buildup, for example, we're using laminated glass on the outside, you can also achieve a very high and significant resistance against intruders. We have tested a couple of varieties, typically around RC2 to RC3. So the question is, how does this work? So on the outside, we have a monolithic glass ply. On the inside, we have an IGU, and in between, a cavity. And in this cavity, the sun blinds are going up and down. And the key issue here is how do we control the air in the cavity? And this is where all the engineering is. So you see this pressure compensation system here on the corner of the element. And we are basically connecting the air in the cavity with the outside air conditions. So we are controlling the partial vapor pressure in the system. Of course, there's some moisture exchange between the outside air and the cavity air. And any moisture which is going through the filter, it's a clean air then going in or out, and any moisture is taken out by the desiccant, which is in the frame of the ISOshade system. And this desiccant in the frame guarantees a very small dew point of the cavity, typically in the range of -20 degrees Celsius to -40 degrees Celsius. So it's really a condensation-free system. It's maintenance-free. We have a design life of about 25 years at least. You do not need any additional mechanical, electrical inputs, no cost for piping systems. So it's really a passive, proven system with no operating or life cycle costs. And what we need, of course, is we need to control the vapor pressure, and this is we need tight edges, we need welded edges. They can be welded. We are using robots to weld these edges, and typically the warranty is 5 years. More if possible, if required. This really depends on arrangement, depends on some details. Typically 2 years, like it's common in the industry for moving and electrical parts. So I will pass on to Adam, and you're going to tell us something about the integrated sun shading, right?
Yes, thank you, Martin. Yeah, so why integrated sun shading? As shown on an earlier slide, Seele has close to 40 years of experience in facade engineering, manufacturing, installing, maintaining highly complex and bespoke structures and facade systems around the globe. They're fantastic projects. They're award-winning, celebrated feats of architecture and engineering. So why an integrated sun shading system now? Well, ISOshade takes all of that experience and that sophistication and performance of a twin skin, or otherwise known as a double facade, and compresses it down into a single line of facade in which a much more efficient dimension is achieved. It reduces all the complexities that come with the twin skins and adds simplicity and elegance. It also takes the challenges and machine complexity associated with closed cavity facades by implementing a low impact, passive, self-conditioning facade solution. By doing so, the sun shading is moved to the glazing cavity where it is protected against the weather. The shading is active, adjustable, unaffected by wind or heavy snow and associated loads. There is no wind noise, no vibration or chattering that is common to brise-soleil. So there's no cleaning requirement of the shading or the inner space workings of the twin skin. They can be connected to a programmable building management system. So Venetian blinds, flat slats. Be it new or be it old, when something works and when something is simple, it should be utilized. And with reference to this, Venetian blinds are providing optimal light control. They provide maximum flexibility. The slats can be tilted so that the incoming light can be directed to suit the individual needs. They provide a pleasant interior climate. The blinds can be opened and closed individually via button, remote controls, or centrally via the building management system that can allow individual customization through the day, as well as programmable positioning based upon time, day, month, and year. That's the position of the facade and geographical location of the project. As a closer look to the Venetian blinds, they're variable. They have rotatable slats available in 2.36 inches or 3.14 inches. They provide individual light control. They provide energy transmittance of 8% to 50%, all of which is optimal for office buildings. So Venetian blinds, the light guidance slats. The light guidance slats, this enables substantial savings for cooling and lighting. There's neutralization of the heat radiation. Shown in the photograph and the image, the W-shaped profile reflects back directional overheating sunlight outwards and upwards. As shown in the photograph and image, this enables passive cooling by reflection, which equals lower cooling costs. The profile shapes also enables light capturing of diffuse light and lower light angle rays of winter sun, which is also known as light shelves. This brightens the room and reduces electricity costs for lighting. Now, vertical awnings. This system is also available with the vertical awning or sunshade. They too can be operated or controlled in the same manner. UV resistant fabrics, screening and shading, providing diffused soft light and a feel-good atmosphere in the space. which is ideal for residential and some office building applications. So how to maintain the sunblind? The system and components have long life expectancies, so we don't expect to have to open them that often. However, it's important to have simple and easily accessible maintenance solutions. The mechanics of the unit are hidden at the ceiling line, such as a drop ceiling space. The motor is exterior mounted to the back of the panel for ease of access, and the back plate is removable with the ability to access the blind unit in whole. So it's in and out, it's very easy. And now remember, when you think about the complexities and constraints and costs associated with a twin skin facade, this is very simple and a compact solution in order to maintain. Okay.
Okay, so where do we see the applications of this system? We are not only looking for the big projects. We start with even one panel. If it's the right project, it's perfect. So you can use it almost, let's say, anywhere. So we can see it in lobby areas, retail, residential, private homes, probably more the exclusive private homes, and of course office buildings. And if we go to the next slides, you can see some typical details for a mullion transom facade, for example. And this shows that you can handle the ISOshade like a panel, like an infill panel, for example, like an infill IGU. Of course, it's thicker than an IGU. It's much thicker than an IGU, but the key concept is identical. So you can use your normal frame system, your normal mullions, and you have tested and proved water and air tightness of the system, and you just need some adaptation for the cover plate to connect it with your profile. If you need some assistance here, we have some solutions out there which we are of course happy to share with you. So from a design and planning point, it's very similar to what we have known so far. It's again with unitized facade systems, you can use your own profiles you have for any unitized systems, and the ISOshade can be handled and is handled like an infill panel, a wide infill panel, 5 to 8 inches, depending on the requirements. If you do not want to see the mullions and the transoms, you can go for an all glass solution, which we can also see for the corners, to typical corners. On the left, more the regular all glass corner. We can also go for a more optimized clear view from the inside. Then we have some bespoke profiles, but more elegant solution. Okay, next one, please. Okay, just we have not shown here is the structural glazed units, but then again, you would just fix it on the top and on the bottom, and you have an all glass structurally glazed unit, which is even more elegant, probably. Antonio, do you want to move on with the some logistics?
Yeah, if we move on to the next slide. Perfect. So we produce the ISOshades elements in our headquarters in Germany. So we feel confident in saying that the quality is top notch. The elements are assembled in a clean room, as Martin explained, and therefore in a dust and dirt-free environment. It is very important for the cavity to be sealed in these environmental conditions. When it comes to packaging and transport, it is fairly straightforward. We will normally use a standardized size truck, and units will be supported on an A-frame and wrapped in foil. So, for example, when we need to ship elements to the US, we will place them in a wooden box for protection, and in order to control the moisture, we will have a desiccant in the boxes. This is much simpler when compared to what is required for transporting panels for a closed cavity facade. The complexities there are much higher because we don't need extra equipment. From an installation point of view, is also straightforward since the panels are pre-assembled. So it's just like installing a glass panel or a regular unitized facade.
So we have been working on this technology for about 4 years now. We have a couple of projects we are going to show you in a couple of minutes. First of all, I would like to show you some very basic test results. We did some long-term testing in the southern part of Bavaria at the, at least in Germany, well-known energetic and room, at the facility for energetic and room climatic investigations. It's so-called FARO. It's from the Fraunhofer Institute. We had about 4 ISOshade systems installed with slight different sun shadings and pressure compensation systems. And we did some long-term measurements for about 2 years. So we measured the outdoor conditions, we measured the surface temperatures, indoor conditions, humidities, differential pressures between outside, inside cavity, and so on. We determined the amount of moisture on the desiccant, and we tested a couple of filters. So it's really long-term tested and also approved by the Fraunhofer Institute. And one important thing, of course, for the twin facades is that we are using high quality materials. First of all, the durability is better, but also we have some let's say harsher conditions in the cavity because it heats up, and the heating up is mainly driven by the sunblind in there. So you should better go for grayish, whitish colors. And all the materials we are using, so the slats, the fabrics, integrated devices, are tested and proved for any fogging. They do not show any fogging behavior, and the sunshades typically have to pass some 20,000 cycle tests, and these 20,000 cycle tests are also at different temperatures to simulate the life of the sun shading. And of course, really depending on the requirements, we can also test resistance for breaking in and so on. We're just showing you some typical curves of the test result in the next slide here. So on the left, you can see the relative humidity in the cavity. On the right, the temperature in the cavity for a selected period of time of, say, roughly 4 or 5 weeks. And in this case, the temperatures are about, one slide back, please. The temperatures are about 40, 50 degrees in this period of time. They can even go up for these double layered facades to about 80 degrees Celsius. And the key here, what we want to achieve is a dry air. So let's take a look at the relative humidity, which is on the blue line on the left diagram. This is the relative humidity in the cavity, and we can see it's a very dry area. There's no condensation there because the relative humidity of the outside air is much higher. And then if you look at the dew point from a technical point of view on the next slide, this is what we're probably more interested in, is what is the dew point of the surface in the cavity? And the dew point tells us at which temperature do we see condensation. And all these temperatures are in degrees Celsius, and we see that the dew point is typically between -20 roughly and -40 degrees Celsius, so very cold, and much smaller than the dew point of the outside air conditions. So really, it's a condensation-free system, which is also what we want to have, of course. Best practice. Adam.
Okay, yes, thank you. Yeah, so a few recent project samples, starting with the St. Afra Diocesan Museum. ISOshade for this project fulfills the highest demands in terms of system performance, design, and transparency. It is a highly sensitive space with precise lighting requirements that must remain constant at all hours of the day, the year round, with a stringent building efficiency requirement. So to introduce a complex operable exterior shading system is impractical from an architectural, technical, and cost perspective. And in this particular project, the existing mullion transit facade was renovated as a part of an important energy efficiency upgrade. To protect the exhibits against sunlight, but also comply with interior lighting requirements for events, the glass facade had to include adjustable vertical blinds. The clients also wanted to create an attractive, homogeneous entrance to welcome visitors. And the customer, in this case, the museum director, has been very pleased and has praised the system and its effectiveness. No noise, perfect light control, perfect system performance under all conditions, including adverse weather conditions, which they get there as well, not just in Toronto. So plus a little effort to keep the exterior surface of the facade clean. So this is the exterior view here. It's designed as a structural glazed system. The museum's ISOshade facade is made up of 3 elements, nearly 22 feet high. They're large format glass units. Elements extend uninterrupted from floor to roof. The elements are clamped to structural members, top and bottom. Vertical joints between the elements are sealed. After installation, the facade was completed within 1 day. It's equipped with a digital twin sensor technology, so we know where the blinds are. And the deeper technical information and system buildup, I will leave for my colleague Martin. But I can tell you that the solar heat gain coefficient of the blind when it's open is approximately 34%, and when closed, 6%. Martin?
Okay, next slide, please. This is okay. Let's take a look at the other project we are just working on now. This is a really interesting building. It's a university in Darmstadt. It's probably pushing glass research in Germany, in Europe to a next level, because this is a building for the students in Darmstadt. Professor Schneider, Professor Knark, who is also working with James O'Callaghan and Delft. And this building is equipped with glass processing technology and machines. So this building gives the university and the students the possibility to really work with glass and to see what's possible with glass. And they also want to have some high-end facade technology. They have some facade testing possibilities there, and the normal glass area is also equipped with ISOshade elements. So we have about 8 ISOshade elements on the west, and about 7 elements on the east. You can see in the next slide. They're about 6.6 times 7 feet. So let's say medium size. We use 60 millimeters, about 2.5 inch Barrie Venetian blinds, and it's a structurally glazed design. So the elements are only fixed at the base and the topped and sealed on the vertical line, like you can see here. We're just going to fabricate them, and we are also working here. If you ever come to Germany, you're welcome to join us in our new restaurant, which is also equipped with the ISOshade element, this bespoke corner element, just next to our stair. And the interesting thing here is that we are also using the light guidance flat Adam just explained, which we're using here in order to reflect a lot of the energy, but to redirect the light back into the room and to minimize cooling and lighting costs. So we expect to finish. We're just producing these elements about 2.5 by 10 feet, 11 feet, and we are producing them just now and installing them next month. And then when Corona is over, we can also have some lunch over there. Another university project, it's interesting that the universities are really going for this product, is in Leipzig. This is a sport use. That is the Institute of Meteorology. About 11 elements, like we can see on the next slide. Again, Venetian blind, 1 corner element. These are vertical awnings, sorry, not Venetian blinds. About 11 feet high, 4 meter wide. Let's say rather standard Innumallian transom facade. A nice project. Another institute in Chemnitz is this. It's about 50 elements we are going to supply. Again, the reason why the architects want to have integrated sun shading here is because you can see the people playing football there and underground, and they did not want to have some internal sun shading because the balls could hill the sun shading and damage it. So internal sun shading was not an option. External sun shading, on the other hand, does not always work, like we just heard. If the wind is too strong or we have some heavy snowy days, you cannot use external sun shading, but you need it if there is some top place in the hall. So the only solution was to go for some integrated sun shading, and we are starting with the design right now and going to fabricate it end of summer. About 50 elements, a slightly larger size, about 8 times 8 feet. Again, these are architectural drawings. Rather, like I just said, it's an infill panel for the design and planning. It's a passive system. The only thing you need there's not any cables you need for this system. Only you need some power for the sun shading to move it up and down, and the connection with the building management system. So you get the ISOshade system with 2 cables, one for the power and one for the building control system.
Thank you, Martin. So what you see here is the showroom. This is the exhibits at in Gersthofen in Germany at Seele's HQ. The ISOshade vertical awning that you see in the picture is approximately 6 feet by 12 feet, and the Venetian blind ISOshade is approximately 6 feet by 10 feet, including an example of an all-glass corner. There's a brochure and system catalog available here in English and German. Soon, Spanish and Russian will also be available. But if you can't make it to Germany to see it, no problem. We also have a video here to watch, and also we'll have some samples in North America shortly. Great. I think we just go back to the presentation there.
Okay. So we're almost at the end, or at the end of the presentation. So in a nutshell, and if we wanted to summarize everything that we just explained, what is ISOshade in a few bullet points? It's delivered as a simple insulated glass unit. However, it is sophisticated like a double skin facade. It also includes integrated sunblinds. The design is flexible, and the end product is a transparent high-performance facade. This is a few bullet points that summarizes what ISOshade is in simple terms. So I think now we can open it to your questions. So let's take a look.
I think we have one question here. It's probably for you. It's always the cost, the classical question. Tony, Adam, do you want to tell us something about the cost?
Sure. I think looking at it in imperial and US dollars, we're about, is it about 120 USD a square foot for the system typically, which is then integrated into a curtain wall or stick system. Something to be mindful is that again we're comparing this system, slim down system, to the performance of what you would have with a brise-soleil or a double skin facade. So when making that cost comparison, you're taking all of this and compressing it down. So you're using a lot less materials. You're eliminating the structure, cantilevered structure that's required to support a twin skin, and in essence reducing the loads on the slab edge structure. So you're reducing that complexity, which is also a cost reduction of its own.
Good. We have another question. Have you used it already in the US? So far, we haven't built a project with ISOshade elements. However, we see quite a bit of interest from developers and also from architects. So we are looking at some early stage projects and seeing how we can bring ISOshade into the project. I think, Martin, maybe this one you want to answer. Can you use curved glass?
Theoretically, yes. They haven't done it so far, but the system is flexible. We can adopt it. You would need an adopted profile depending on the curvature, of course, but we would use an adopted profile, and then we can also go for a curved glass. Depends a little bit on the radius and tolerance and accommodation, but yes, it's possible.
Any more questions? Okay.
So,
We must have explained everything. That's not too many questions, but if you have further questions, as noted, please feel free, first of all, to visit the website, seele.com/facades/isoshade, so you can definitely pull up information. But myself and Antonio as well, from a regional point of view, myself in Canada, Antonio in the US, please feel free to reach out to us, and we'd be happy to discuss the product further, as well as take a look at any potential project opportunities that you might be considering. We can review that with Martin and his team in Germany. So,
Thank you very much.
Thank you.
thank you, everyone.
Okay, everyone stay safe. Thank you very much.
Stay safe. Thank you. Bye-bye.
Bye-bye.